Alright guys, I'm sorry I didn't have this review done sooner. I wasn't feeling great on Friday. I'm not feeling great now, but I got to get my work done, so here I am. I'm going to do both of these, this one and this one. I'm going to do the yellow one first because it was the first one, and then I'll do the review. I have the answer key up so that I don't make too many mistakes, but you know, if you see something wrong, there's a real good possibility it is wrong, so just please feel free to let me know. You might hear cats running around, you might hear cats eating, you might hear Molly come over and real sleepy say, "What are you doing, Mommy?" You might hear stuff. I don't know how long this is going to take me, so you remember, fast forward to the parts you want. Everything's good. Okay, so first of all, I got to get another highlighter because I told y'all I'm using the double highlighter strategy, so now I'm digging around in my drawer for my pack of highlighters, which thank goodness I found. I am going to use my favorite combination. Well, actually, my favorite combination. You know what? I have my favorite combination. What am I doing? It's green. It's purple and it's blue and pink. Make purple. Okay, so let's read this one. It says, suppose you intend to spend no more than $60 buying books. Hardback books cost $12 and paperbacks cost $5. Let X equal the number of hardback books and Y equal the number of paperback books. I know I did this. I think I did some of this with you in some of your classes. This might have been in your notes. But I'm going to do it anyway. So remember, we take our first highlighter, we highlight everything. Well, first of all, we highlight the variable. X equals the number of hardback books. And then everywhere I see hardback books, I highlight whatever they tell me about it. And then I see hardback books here. Hardback books are X, so I'm not going to maybe do the full highlight, but I'm just going to kind of lightly highlight the X-axis in pink. Okay, so I've highlighted everything hardback book related pink. Now I'm with my other highlighter, I'm going to look for the other variable. It says Y is the number of paperback books. So I'm going to highlight everything Y related, so everything paperback, in my blue highlighter. And that means, again, I'm going to lightly highlight. Wow, that took a turn. I'm going to lightly highlight the blue axis, except for that one weird there in the middle. I'm going to lightly highlight it blue. Now, you know you don't have to use as many highlighters as I do, but y'all use whatever highlighting you need to. Okay, so now it says, write an inequality that represents this situation. So remember, the strategy I taught you guys was to write the caveman sentence. So I'm going to write it here. It says, oh, I forgot something, y'all. I forgot to circle the inequality. So I'm going to write, it says hardback, so hardback and paperback no more than 60. Okay, and now I can't zoom in. Y'all are just going to have to kind of get your zoom on. Well, I guess I could, but like there's only so close I can get this thing. As it is, you see how close, if I stand my pencil up, boop, I'm just boop, right there. So I'm sorry, it's best to watch this on a screen. So that means hardback is X and is plus, Y is paperback, no more than. So remember, the strategy for that was I would write greater, equal, less than 60. If I'm no more than 60, can I be greater than 60? No. Can I be exactly 60? Wait, yes. Can I be less than 60? No. So less than or equal to 60. Now, this is money, this is number of books. So I got to do something to make them money. So if I multiply each paperback book by 12, and I'm sorry, each hardback by 12 and each paperback by 5, then I have my inequality. Now, to graph it, there's a couple things I can do. I can use the cover-up method. So I could say, okay, 5y less than or equal to 60, y less than or equal to 12, and then put a dot on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Put a big old dot there. And then I could say 12x less than or equal to 60, x less than or equal to 5, and then I put a dot on 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, and then I connect them, and then I use a test point to decide where to shade. The other thing I could do is I could convert it into slope-intercept form. So I could say, I'm going to write this kind of, I got space back here. I'll write it on. So I could say 12x plus 5y. Let me see if I can focus this. That's a little bit better. Less than or equal to 60. I could solve so that y is by itself. 5y less than or equal to negative 12x plus 60. When I divide everything by 5, I get y less than or equal to negative 12/5 x plus 12, which actually works out to give me the same thing, right? So y, let me write that down, less than or equal to negative 12/5 x plus 12. Well, that means my y-intercept is 12, and my slope is negative 12/5. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I go right 5. 1, 2, 3, 4, 5. I ended up putting the same points down. Now it says less than or equal to, which if I had plugged in 0, 0, I would have seen the same thing. First thing I got to do is connect the line. Is the line going to be, I'm trying to find anything with a straight edge, so here's a thing of toothpaste stuff. I can't find my badge right this second. Okay, so I connect them. Now, these are paperback books. I can't have negative paperbacks. I can't have negative hardbacks. So I cannot go past 0 or 0 in here. And it's less than or equal to, that means it's a solid line, and I shade below, which, why not? Let's just use a third highlighter color, because this is my life now. Lost in a sea of highlighters. Okay, so then I would be highlighting just in this area right here. So that was a lot for the first problem. I'll try to go faster going forward. Okay, so now it says, now there's two ways. I could plug these in and see if it's true or false, or now that I've graphed it, I can plot them. So if I plug them in, I'd say 12 times 2 plus 5 times 5 less than or equal to 60. Okay, well, with my calculator, which hopefully is not dead, because that would just be just about right here, I would say 12 times, I'll brighten this down so you can see it, 12 times 2 plus 5 times 5, forgot to put the 2, didn't I? Yep, sure did. That's 5 plus 5, second math, and this is less than or equal to 60. Is that true? It says 1. That means yes, it's true. Likewise, if I just plug in over 2 up 5, I'm in the shaded area, so that's true. So I'm going to do that way for now. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one looks true. Okay. Over 4 up 4, that one's outside of my shaded area, so that one's false. So these are true, that one there is false. Over 6 up 2, that one's false. Okay, over 1 up 2, yeah, that is 1,000,000% true. Over 3 up, yeah, I don't think that one's going to be true. That one's false. Over 3 up 3, and that one is true. Okay, so the plots in the plots on the table that I said were true, and the plots on the graph, they are located, they're in shaded area. We could have also plotted 5, 0 or 0, 12, because they could also be on the solid line. Okay, so I kind of wish we had a point like that in the table. Okay, I'm going to go a little faster on this one since I did all the heavy lifting. So any future graphing problems, I'm just going to like graph them. I'm not going to have a big old conversation because I've already spent 9 minutes on this first problem. So as you can see, there's going to be a thing. Okay, suppose your class wants to raise more than $150 for the Red Cross. You make $5 on each basket of candy and $3 on each box of cookies. It says let X equals the number of baskets of candy, and then hold on, $5 on each basket of candy, and okay, and then you make, and let Y equal the number of boxes of cookies. So Y equals boxes of cookies, $3 on each box of cookies. Okay. All right, so I'm going to write my inequality. I have $5 for each basket of candy, and I have $3 for each box of cookies, and that should be more than. So that's, if it's more than 150, it's got to be greater than, but it can't be equal. That's 150, by the way. Can't be equal, it can't be less than. So greater than 150. Okay. So I'm going to do this by solving the inequality. It says in the table, there are given values. Determine 3 possible values for solutions for each value given. So what I'm going to do is, I don't know what y is in this one. So I have 5 times 10 plus 3y is greater than 150. So I'm going to actually solve this. That's 50 plus 3y greater than or equal to 150. And I'm just solving this equation, which we should be real good at by now. Y is greater than 33 1/3. So basically any value greater than 33 1/3. So if you put 34, if you put 500, if you put 6 million, anything bigger than 33 1/3. You can't include 33 1/3 though. It's got to be bigger than that. And honestly, what's a third of a cookie? You going to sell somebody a third of a dozen of cookies? No. Wait, is this box? You're not going to sell somebody a third of a box of cookies. So it's got to be whole numbers. Remember, always keep domain and range, discrete and continuous in the back of your mind. Okay? We'll do the same thing. I'll do the same thing for these 3. Again, for this one, it's a little different. This one, I get, hold on, 5 times 10, whoops, sorry about 5x plus 3 times 23 greater than 150. So 5x plus, I don't know what 3 times 23 is. What is it? 69? 3 times 23. Oh, I can do some math in my head. 69 greater than 100. I'm sorry, 150. This is, I can't read my own handwriting, hazard. Minus 69 minus 69. 5x, I do 150 minus 69 is 81. Greater than 81. Divided both sides by 5, I get x divided by 5 is greater than 16.2. So again, here we're going to put anything bigger than 16.2. Okay, anything greater than 16.2. All right, I'm going to, well, I can't pause it. I don't think I can pause it. Can I pause it? Yes, I can pause it. So I'm going to pause it, and I'm going to do the other 2 for you. All right, so when I work these 2 out, I got 16.2, so I got x is greater than, wait, hold on a second. I wrote 16.2 because I'm a ding-dong. But we're not making marks for this because I don't feel great. And of course I can't, hold on, I can't find an eraser. Give me a second. Let me pause so I can find an eraser. Okay, found one. So this one should be anything greater than 21.6 repeating, so 20, like 22, 23, 24 and higher. This one is anything greater than 26.4, so 27, 28, 29. You kind of see where we're going with that. All right, so let's take a look at this one down here. This one is actually kind of tricky because again, but the best way to solve this is caveman sentence. So it says John spent at most 5 more than K on dinner. Yoy. Okay, so first thing I'm going to do, so this is a multiple choice question, so this gives me a lot more choices. But I'm going to write John at most 5 more than K. All right, so that's my caveman sentence. John at most 5 more than K. Now, at most, we're going to say at most 5. Okay, so that's greater, less than. So if I'm at most 5, can I be greater than 5? Well, the most I can be is 5, so I can't be bigger than 5. The most I can be is 5, so I could be exactly 5. The most I could be is 5, so I could be less than. So I could be less than or equal to. I probably should put that where it goes, sorry. So I could be less than or equal to. Now, let's assume that I know I don't know about a sign flip. I know it can't be this one because it's got the wrong sign. Okay, So I know that, and it says A is John. Oh my God, seriously with this. A is the amount of money John spent, and K is the amount of money K spent. Don't you think using J would have been better, but whatever. So A is at most 5 more than means plus 5, and K is K. So plus 5K sounds dumb, right? So I would do K plus 5. Well, these two say K minus 5, so we know those. This one is super not it. This is less than or equal to, and this one is greater than or equal to. So I'm pretty sure it's got to be this one. Let me check and see if I'm right. Okay. All right. Let's look at this one over here. Go me. I can math. This is very exciting. Probably very exciting for you too, since I'm your teacher. Okay. It says Jill wants to earn at least $2,000. So I'm going to circle that. At least $2,000 to put towards the purchase of a car next year. To earn the money, she'll mow lawns for $12.50 and shovel snow for $20 an hour. So it says let X equal the number of hours mowing lawns. She mows lawns for $12.50 per hour. Okay, and then we're gonna. It says let Y equal the number of hours shoveling snow. So Y is hours shoveling snow, and she gets 20 an hour shoveling snow. Okay, so first thing I know is I know that like 12.50 and X have to go together. So I'm going to go and look for that first. Well, this one doesn't have 12.50 with X. I also know that 12.50 has to go with Y. And wait, what? Oh no, 20 has to go with Y, my bad. And so we've eliminated C completely. Okay. Now I'm going to look at, so again, I could write, I already know the rest of this is right. Now I need to look at the inequality sign. So it says at least 2,000. So I'm going to do my greater, equal, less than. At least 2,000. Okay. So if I have at least 2,000, can I have more than 2,000? Yeah, I totally can. If I have at least 2,000, could I have exactly 2,000? Yeah. If I have at least 2,000, can I have less than 2,000? No. So it's got to be greater than or equal to. Well, this one isn't or equal to, and this one is less than or equal to. So it's got to be B. Yep. Okay. Now, so hopefully that's good. In basketball, you score 2 points for a basket and 1 point for a free throw. Suppose you scored no more than 17 points in a game. So I'm going to look at no more than 17. Okay. Good Lord. Okay. It says X is the number of 2-point baskets. I guess that's like regular baskets. Don't judge me. X is the number of 2-point baskets. 2 points for about, oh yeah, duh, okay. And then they don't even talk about three-pointers, but we're not there. Okay, and then it says Y is the number of free throws. Y is the number of free throws, so you get 1 point for those. And it says the inequality is 2x plus y is less. Oh, look at that, they gave it to me. Okay, so it says if you make 4 baskets, what's the maximum number of free throws you can make? So 2 times 4 plus y less than or equal to 17. Okay, well, 8 plus y, there's not enough room here. 8 plus y less than or equal to 17 minus 8. Y less than or equal to 9. So you could make 0, oh, the maximum number, so you can make 9 free throws. So I was about to say I could make 0 to 9 free throws, but it says the maximum numbers. If you make 6 free throws, y is 6, what's the maximum number of baskets you can make? So 2x plus 6 less than or equal to 17. 2x less than or equal to 11. X less than or equal to 5.5. Okay, so just riddle me this, Batman. Can I make half a free throw? No, so I would have to say 5 free throws. Because remember, I gotta have a whole number of throws. I can't have half, but I also can't round up. Even though this number looks like you'd round it up because it's 5 or above, give it a shove. I can't round up because if I round up, then I'm saying 6, and 6 is not less than or equal to 5.5. You kind of see what I'm saying? So we really got to think about what that inequality sign means. So 5 free throws is the most I can make. So now it says, is it possible to make 7 baskets and 4 free throws? So baskets are X, so 2 times 7, and 4 free throws plus 4, is that less than or equal to 17? Well, 14 plus 4 is 18 less than or equal to 17? No. And I'm not going to write it down, but the explanation is, if I made 7 baskets and 4 free throws, that would be 18 points. And I made less than, I did no more than 17, so I couldn't have made 18, so that can't be it. I could have had 7 baskets and 3 free throws. That I could have done, but not 4. Okay? All right, so that's that question. It says, which inequality below best represents this graph? So when I approach a question like this, the first thing I'm going to do is I'm going to look at the boundary line. Is it dashed or solid? So this line is dashed. So that means it's got to be one of these two. Well, this one says or equal to, so I know it's not C. I've already eliminated C. Okay. Now, next thing I'm going to do is I'm going to still look at that line. So I'm not even looking at shading yet. I could look at shading. It's shaded above. And if I did look at shading, then that would leave me with 2 possible answers. But I'm going to look at the slope of the line, because again, that's easy to tell. So I sign a line. This line is negative slope. Well, look at that. This one has positive slope, so these two can't be it. The only one left is here. Also, it happens to also be shaded above, which means it's got to be greater than, so that one would have been out anyway. Okay, so remember, this is the reason why knowing those key features is so important, because again, I almost didn't even have to do much with the inequality. I didn't have to know where to shade, because all I had to do was look at the line. So let's see if that, let's see, that strategy is not going to help me here, is it? Now, this is a problem. So remember I've been telling you guys about the cover-up method? This right here is a problem where the cover-up method is like really useful. Okay, Izzy, you cannot be here right now, baby. Hold on, I gotta make a place for the cat to sit, or else she's gonna be bothering us. By the way, this is Izzy, the sweetest cat. See? Hi, Izzy. There you go. All right. Okay, so now that we've got Izzy situated. Okay, so for this one, the cover-up method works really well. Okay, so first of all, first thing I'm always going to do is I'm always going to look at the boundary line, because regardless of whether it's in standard form or slope-intercept form, the boundary line, I can at least figure out if it's supposed to be solid or dashed. Okay, so this is solid. Where solid means if I see the line, if I see a solid line, then I have the line in my inequality, so the underline. If I see the line, I have the underline. Okay, so it's going to be one of these two signs. Okay, well, I see that this one and this one are immediately eliminated because they don't have or equal to. They're just great. Izzy girl, you need to sit and slow your roll. You need to stop nuzzling everything. You need to lay down. I made you this nice bed. I'm sorry, you guys. There we go. That's better. Okay, that's what's up. I'm sorry, that just happened. Okay, so now I'm going to look at these two. Now, I will tell you right now, I think the best strategy for this one isn't even the cover-up method. It's using the test point. I've eliminated 2 answers, okay? And the only real difference in them, you see I have positive 2, wait, I have 2x and negative 6x. So I'm going to try a test point, okay? It's not very hard, okay? I'm going to look at 0, 0, because again, I'm going to do anything I can to not have to take the time to convert these 2 things into standard form, into slope-intercept form. Okay, so I'm going to try it on both of them. Even if it works on one, I'm going to try it on the other. So 2 times 0 minus 6 times 0 greater than or equal to 12. Okay, well is 0 bigger than 12? No. Is it? Am I wrong? 2 times 0 minus 6 times 0 greater than or equal to 12. That's not true. Okay, well this one says negative 6. Yeah, that's not true, and that's what I want. Okay, so this one, sorry, that one's looking good. Sorry, I had a moment. I was like, but that's true. So yeah, so again, if it's not true, it's not in the shaded area, so I'm looking for a false answer. This one is false. So negative 6 times 0 plus 2 times 0 is also less than or equal to, is that less than or equal to 12? Is 0 less than or equal to 12? That's true. This is false. I want the false answer, so A is it. Now that's kind of weird. So let me explain. I use 0, 0 because it's the easiest test point to use. All right. So with 0, 0, since it's not in the shaded area, that means it's not part of the solution set, and so it's a false point. So I'm looking for an answer that's false. When I look at this, I get 0 greater than or equal to 12, which is false. When I do this one, I get 0 is less than or equal to 12, which is true. I want a value that is false, which is why I picked A. I know that's really backwards thinking, but if you like, my first instinct was to circle D. I'm gonna be honest with you, because it's true. And remember, there was a problem we did a couple of days ago where I got lazy and I just tested the test point and it was false like the thing said, and I picked it. That's what I was, anyway, I'm going to stop talking. Hopefully I can answer this question for you on Monday. But yeah, so since it's not in the shaded area, that means 0, 0 is false. I'm looking for an answer where 0, 0 is false, and A is that answer. Okay. Okay, now this one says, which ordered pairs are solutions to the following inequality? All I'm going to do is substitute them in. So -2 times 0 plus 5 times 0 should be less than or equal to 10. Okay, is 0, and again, how am I figuring out 0? Okay, so I'm taking clear, -2 times 0 plus 5 times 0, and I'm seeing if that is less than or equal to 10. And again, I'm checking that. All I did right here was write down what I substituted in. I got a 1 for that, so this one's true. I'm going to do the same thing here. I'm just going to recopy my line, and I'm going to put in those values. -2 and negative, I'm going to insert 4. So now I've done the substitution. 2 times -2 plus 5 times -4 should be less than or equal to 10. And it is, so I circle it. Let's try 3 and 5. 3, 5. And I get 0. That one's false. Okay, let's try -3, 2. -3, whoops, 2. That one is also false. Let's try 5, 4. X is 5, Y is 4. That one's true. 6, close enough, we'll just use this one. 6, -3. 6, negative, insert 3, and I get true. Okay, again, this is straight calculator work. All right, now, this one right here is very similar to these two up here, except instead of giving, so it's very similar to number 5, but instead of giving me like, instead of giving me like an X and a Y, instead of giving me like a situation where they say free throws and baskets, they're just giving me numbers. So 3 is X, I'm looking for Y. So I'm going to say 4 times 3 plus 2Y less than or equal to 16. I'm going to do the same thing, 12 plus 2Y less than or equal to 16. This zeroes out, 2Y less than or equal to 4, Y is less than or equal to 2. Okay, so that's the answer. Now it says write a possible value. So literally anything you write that's less than or equal to 2. So if they gave you a list of numbers, like if they said 5, -1, 0, -18, and they said one that's, well, if they said -2, 8, whatever number they gave you, if it was less than 2, it would be true. Kind of make sense? Now for this one, I'm going to plug in a -10 for Y. So I'm going to say 4x plus 2 times -10 less than or equal to 16. So 4x minus 20 less than or equal to 16. I'm going to add 20 to both sides. 4x less than or equal to 36. When I divide by 4, I get x less than or equal to 9. Okay, so any value less than or equal to 9 is going to make this true. All right, I'm going to pause for now. I'm going to upload this video, and then I'm going to make a separate one on the review, because when I talk my way through these things, they take forever.